Subhashri from SNSCT, Department of Computer Science and Engineering. We are going to see about the process of machine learning now. So the steps involved in machine learning process are data collection, preparation, choosing learning algorithm, and training the model, evaluating the model, and doing some predictions. So what we have to do here is, first of all, data collection. In this stage, data is collected from different sources. Sources in the sense the historical data. The type of data which is collected depends upon the type of the desired project. So data may be collected from various sources such as files and databases. For example, we can collect the data from the hospitals about the patients. Okay. So the historical data, what are the patients and what diseases they have been attacked by. Those are the sensational data that we can get it from the databases. The quality and quantity of gathered data directly affects the accuracy of the desired system here. So we have to gather the data in the formation where we can give the correct output. So the data preparation. In this stage, the preparation is done to clean the raw data. Collected data from the real world stands from a clean data set. Here clean in the sense the necessary data are said to be as clean data set. So the raw data which may contain missing values such as inconsistent values, duplicate instances, etc. Duplications in the sense repeated data. So raw data cannot be directly used for building a model. Different methods of cleaning the data set are ignoring the missing values. For example, if the values are missed, we can't use it for training a data model. So we can ignore it. So removing instances having missing values from the data set. Estimating the values of instances using mean, median, and mode. By using the formulas for mean, median, and mode, we can estimate the missing values. Because the previous data is also there, and the data which comes after the missing value is also there. By using that, we can find out the missing value by using a formula mean, median, and mode. Removing the duplicate instances from the dataset, normalizing the data in the dataset. So the raw data cannot be directly used for building a model. This is the most time-consuming stage in machine learning workflow. Next, how to choose a learning algorithm. Why choosing an algorithm is mostly widely important. Here, the best performing learning algorithm is researched and analyzed. It depends upon the type of problem that needs to be solved and the type of data we have to solve. So if the problem is to classify and the data is to be labeled, classification algorithms are used, because we already know labeled data are called as classification algorithms. Okay, so the problem is to perform a regression task and the data is labeled, regression algorithms are used here. If the problem is to create clusters and the data is unlabeled, clustering algorithms are used. If the data is labeled, it is a classification problem. The data is an unlabeled data, it is a clustering problem. Okay, so that is classification in the sense it is a supervised learning part, and clustering algorithm in the sense it is an unsupervised learning part. So the following chart provides an overview of learning algorithms. See, machine learning, which is divided into supervised and unsupervised learning. Here, the supervised is divided into classification and regression. So, the algorithms which comes under the supervised learning, that is classification and regression, is as follows. So, key nearest neighbor. So, we will find how many number of datas are there. We can split the datas as k. That is, number of datas is k, and k nearest means the data next to it. So, navy base, decision trees, support vector machines, and logistic regression, these all comes under the classification. Whereas regression algorithms are linear regression, support vector regression, decision trees, Gaussian progress regression, and ensemble methods. Whereas in unsupervised learning, we can see Gaussian mixtures, k-means clustering, boosting, hierarchical clustering, spectral clustering, etc. So, training the model. The model is trained to improve its ability. So we have, for each and every instances, we have to train a model, because the model is going to think like a human, so that it needs to take a decision on its own, right? So the model is to be trained to improve its ability. The data set is divided into training data set and testing data set. Here comes what is meant by the training data set and what is meant by the testing data set. Training in the sense, we will train the model based on the historical data, that is past data which is collected from the databases and files, etc. The testing data set is nothing but, for example, if we have n number of data, let us take 10. So there are 10 data. In that 10 data, I am going to train the model by using 8 data from it. First 8 data. The next 2 data I'm going to take as a test data set. Based on it, what will be the output? Again, I'm going to take 8 data sets, but now I'm going to include the 2 past data sets which are using as a testing data. I'm going to train it now, and another 2 random data are taken for testing the data set. Okay, from this we can improve the model's ability so that all the data in the data set are used as training and also as a testing. Okay, for the training and testing split in order of 80 by 20 or 70 by 30, we can take 8 data sets and 2 data sets separately, or else 7 3 6 4 5 5. We can take any number of data sets as testing and training, but we have to utilize all the data in the data set so that the model's ability can be improved. Training dataset used for training purpose. Testing dataset is used for the testing purpose. Training dataset is fed to the learning algorithm. First, we have already seen the algorithms based on classification, clustering, and regression, right? So based on that, we can train the dataset to the learning algorithm so that the algorithm will learn about the data and it will fed the data as an input to the model so that the model can predict what will be the output. The learning algorithm finds a mapping here. So what is meant by an evaluating model? In this stage, model is evaluated to test if the model is any good or not. Model is evaluated using the kept aside testing dataset. We have already classified the data as training dataset and testing dataset, right? So the model is evaluated only by means of the test dataset where the model should give a correct output, accurate output. If it is not, again we have to train the model based on splitting the data, whereas it can be 8 by 2 or else it can be 7 by 3. Okay, metrics such as accuracy, precision, recall, etc. are used to test the performance. If the model does not perform well, the model has to be rebuilt using different hyperparameters. Accuracy may be further improved by tuning the hyperparameters here. So what will be the prediction? And then this is the last stage where the building the system is finally used to do something useful in the real world. Here the true value of machine learning is realized. Again, the training dataset and testing dataset will go away. We will not use it further. What we are going to do now, it is going to be in a real-time environment. The model is going to predict a new value based on the previous datasets from which it is trained. Okay, here the true value of machine learning is realized. So thank you. Let's see in the next video. Thank you so much.